So there are four important properties of class and objects which we need to remember. Okay. So what are those four important properties? You have inheritance. Okay. Encapsulation. Then you have polymorphism. Then you have abstraction. Okay. So these are four different or four properties, okay, of class and objects, and which we need to remember very well. Okay, need to remember because the, these are important. Okay, and it's easy to understand. Okay, we'll take one example and we'll talk about it. So inheritance is when one class extends the properties of another class. Okay, so let me do one example and show you. So let's say I have a class called school, let's say. Okay, and it will have init, right? And here I'm defining school name equal to school name. Okay, and this we have school name that is being passed to it. Okay, and then it has a um, it has a method called display school. Okay, and you say print school name is fine, and then you say self dot school name. Okay, okay, so you get this method is in school. So now let's say if I create an object of school. Okay, so I'm going to say s1 equal to school. Okay, and so s1 becomes object, right? So I have to pass the school name. So I'll say ABC International School, let's say. So now you created an object. Now if I say s1 dot display school, okay, what do you, okay, it's pointed to different file. Okay, so it says school name is ABC International School. Okay, now let's say we create another class, and this time I'm creating class called as student. Okay, I create class called as student. Okay, now when I create a class student, okay, student will have school name and also student name, right? So so say for student also you want to put school name. So now you have two options. Okay, one option is you can say init school name comma student name, right? And then you say self dot student name equal to student name, and then you say display school and display student. Sorry. Okay, so now when I create a student record, I'll say st1 equal to student. Okay, and it takes two things, right? So I give Sachin and I give XYZ International School. Okay. So now when you run it, okay, and I can display, right? I can say st1 dot display school, st1 dot display student. Okay. So if you do this, you get Sachin XYZ International, right? Now, here you see, okay, um, this is display school is exactly same as display school here. Okay. So why do we have to duplicate the code? Okay. There is no need to duplicate the code. Okay. So in this case, it's like, you know, let's assume, this is father and this is daughter. Now, this daughter, okay, also has something and father already has something, then why do you want to create? We can create that relationship. So it's called inheritance. I can say here student, I'll put bracket here and I'll say school. So I'm saying that student extends or inherits properties from school. So you don't want to duplicate the effort. Okay, there's no need to duplicate the effort. If school already has the display school, and if this is exactly same meaning, same thing, then why do you have to duplicate it? Okay, there's no point duplicating it, isn't it? So we shouldn't, okay, we should reuse the code as much as possible. So its purpose is to reuse it. Reuse the code as much as possible because it's exactly the same. So you delete this here, okay? You delete this. Now, when you create this inheritance property here, right? All the properties of school is now available for student. Okay. So now even like, uh, if you like display school we deleted, right? So if you delete display school here and you say display school, you see, you are getting it. So it becomes, so all the properties of parent is now available. We call this as base class or parent class, or this is your derived class or child class. So derived class will have all the properties of the parent class. Parent class cannot, right? As a parent, you can't access your kids' stuff, but your kids can access your stuff. Okay, that's the rule. So here, that's why we don't mention it, right? So on your other, on your documents, you will not have kids' name. You'll have your parent name. Your parent, your student, your kids will have your name on their documents, right? So it's like student having parent's name in the document. Okay, you can access nothing from child, but child can access everything from parent. Okay, that's the relationship between, when you talk about inheritance, inherits. Okay, in English also we have words inherits, right? You inherit the properties of parent. So the derived class will inherit, it will inherit the properties of parent class. Okay, so you don't have to duplicate, they can. But here there's a trick here. Okay, um, display school has school name which comes from this init, but when you run it, okay, so school name, what happened? Oh, I put school name here, right? It is school name first and names. Okay, now you see, now it works fine, right? So student is able to display the display school from here. Okay, this is called inheritance. Any question here? Now, me. Okay. So you can have parent and child, right? So this is your base class. This is your derived class. What it says is there can be any kind of relationship. You can have two base class, three base class, no problem. So if you have two base class, three base class, right? You will put, like in this case, student, and then you can say school, comma, district, comma, city, comma, whatever, right? You can put. So all of the properties of all these is now available to student. Properties of all this is available to student. Okay. You can have child class in it. You can have multi-level. Okay. So now in this case, if this class is C and this class is B and this class is A, so C will have all the properties. Through B, C can access A's and this all properties here. Okay, because all these properties available here. So C can access B. So automatically all of these will be available to C also. Right? And how to create the relationship? Just by using bracket and comma. You get it? Okay, so this is called inheritance. Let's go back to our program. Let's add few more. Okay, so one thing I wanted to say, since we have same name here, right? So it could read this, but let's say here I put different name. I put different name. Okay. Now when you run it, it says student object has no attribute school name, right? So if name variable is different, you can actually do that. What you can say here is, in this, you can say that, okay, this init is the school name is same as S name. So you will call school. It's not always possible to give same variable name, right? So you say school dot init. Okay. And of course, you don't have to give for self. And here you can pass S name. So you are specifically calling init to initialize the variable school name with S name. So now it, oops, sorry. What happened? School dot init requires, okay, so here you have to say self. Yeah. So see, it worked fine. So you can call init function from, so see, since it was same variable name, so when it was trying to display the school name, it could figure out, okay, this is the school name. But when you have different name here, S name, it doesn't know. We have to tell that S name is same as school name. So you have to define here S name so that S name goes to now school name. So you're calling this init specifically. Okay. So now let's say you have one more um, one more function here called def display LOC location. Right? Now you say print. We are located in the city. Okay. Now, since this is in school, your student dot display location will also be available. So when you run it, we are located in school. Okay, you see that. Now, print school can also call display location. So it is self dot display location. Okay, this self dot display location. So your display school will also have this. Okay, so I can uh, uh, okay, so you have this, right? So now you'll have twice. We are located in city is coming from display school, and you have independent. This also can be called. Okay. Now, what does polymorphism means? Polymorphism means that we can have multiple forms. Okay. Now you see here, you have display school, which is not here. So you have only one display school, right? You can have, now let's say if your display school, or let's say display location, right? Now student will get display location. But let's say student display location is different. You're talking about home, let's say, for student. So you can create this one with the same name, okay? Because if you create different name, display location will be available to ST1 from the parent class. But I don't want parent class display location to be called. I want only school name to be called. Display location, I want to have something different. Calling from student class. Okay. So now when you run it, see it says we're located in the city. Now when you run it, okay, calling from student class. Okay. So calling from student class here. And here also it is from student class, because object of student, okay, if it has its own property, it will not take parents' property. Okay. So as a student, as a child, if they bought their own car, then it will not have access to your car. Only if they don't have it, that's when they will take your stuff as a parent stuff. Is it clear? So in this, you see, student school name is not there in the derived class. Since it's not a derived class, it's taking from parent class. But if you talk about display location, object the student class has it. So it is not going to take. So you can have functions with same name. Okay, you can have functions with same name. It depends upon, okay, the rules. There are various rules based on which it knows which one to pick. The first rule is that if you have function in both parent and child, base and derived class, and if you're creating object of derived class, only derived class function will be called, not parent class. And if it is parent class object, then of course parent class uh, uh, method will be called. Okay, that is rule number one. Rule number two is, now again, if you come from Java and the background, it is different here. Here, you don't actually have same name function in same class. In class, you cannot have two function with same name. Okay, even if you create two function with same name, the last one that you created will be considered. So let's say if you create display location, display location, display location 3 times, the last one that you have created will be taken into consideration. Above that, whatever you take will not be taken into consideration. Okay, so this is again your rule of polymorphism. Okay, in Java, C++, you can create functions with same name, multiple functions with same name you can create, but in Python you can't create more, function with same name in the same class. Okay, so if you talk about this very example, okay, now let's say I create one more display location. Okay, and I create one more display location, same name, and this time I add some variable here. Okay, so now when you call it, it will give error saying that LOC is missing. Okay, it is not calling this one. It is calling this one. So it is expecting you to pass a variable for LOC. So if you can, even if you have multiple methods in the same class, it's not going to accept. This is called polymorphism. Okay, you can, if you have multiple methods with same name, then polymorphism decides which one to call. So two rules to remember. If derived class has its own function, it will call its own function even if parent class has it. It's only when the derived class does not have its own function, it will call base class function. Okay, rule number one. Rule number two, one class should have only one function with same name. Okay, same name I'm saying. So if you create, you can create. It's not going to throw error. It's the, creating function is not throwing error. What is throwing error is calling. So when you only last function is available for use, previous to that, all the other functions are not available for use. Okay, so it doesn't matter what you create, but only the last, okay, function will be available for us to use. Okay, so there is no point creating more than one function with same name. This is your polymorphism. Inheritance. Inheritance is inheriting properties from parent class. As a child class, you have access to the parent class properties. Polymorphism is when if you have function with same name, then what to do, right? The third is called encapsulation. Encapsulation is also called as data hiding. Encapsulation is also called as data hiding. Okay, you are hiding the data. Okay, now for example, okay, you have let's say, let's create one more function. Okay, here in school. Okay, so what I'll do is, okay, this one I'll delete it. Let's say display state. Okay, I'm just saying display state. I located in the state. Okay, now I put display state here actually. Okay, not LOC, display state. Okay, fine. So now when you call this, okay, you get we are located in the state. Okay, now when you try to call student, we can call student dot display state, and it is very much available, right? Display state, right? So I'm going to copy this. So display state is a function in parent class which will be available to child class also as per our inheritance properties. Okay, it is available, right? Now let's say if parent class doesn't want, okay, child class to access its member. So by default it is available, but as a child class, as a parent class, you can stop. You can say no, I will not give you. Okay, so that's called encapsulation. You are hiding the data. So let's say we have two departments, finance department and HR department. Okay, so there are some data which finance department will be ready to share with HR department. Okay, so in this case you have display location, display school, which school is ready to share with the child class, with the HR department. But there's some data which you do not want to share with HR department. Let's say display state, we don't want to share, but using inheritance properties, it is automatically shared, right? But how can we avoid it? I want to avoid, I don't want to share this method or function with the child class. Okay, that is, we can do, you can perform that with property called as encapsulation. So encapsulation means hiding. Okay, you are hiding, so they use something called as public, protected, and private options. Now protected, okay, concept exists in Python, but practically it is not implemented yet. That means protected word is there, okay, but it is not implemented. So in practice, you only have public and private. In practice, you only have public and private. You don't have protected. Okay, so we don't talk about. I mean, we cannot implement protected and show you. So concept of public is okay. Okay, so these are your encapsulation. Encapsulation. Public is the members, okay, and it applies for both variables and functions. Okay, so members are available to be accessed by anyone. Anyone can access. Okay, that means if you have a class here, okay, school, and let's say I declare a class, another class called class myself. Okay, and I do not extend this. I do not inherit. Still, I can say school dot display location. Okay, now I'm not inheriting. See, I'm not inheriting. So now if I create m1 equal to myself, okay, and if I say m1 dot, okay, okay, so what I'll do is I need to create a function, right? I'll create a function def myself method. Okay, myself method, and this is calling school dot display. So I'm m1 dot myself method. Okay, and you call it. Okay, so okay, you have to say self here. Okay, when you're calling from class, you have to say self. Okay, so see, since it's a public, okay, public methods or members can be called from anywhere, even though myself is not a derived class of school. Okay, to make it derived, I have to put school in the bracket here. I did not put. So myself is third party. You can call it from anywhere. So public means anyone can call it. Anyone. You know, even if it is not your derived class, you can call it. Okay, and not by anyone. Protected members can be called only by its own functions and derived class functions, called by its own and derived class. Okay, so public, you don't write, public is just like this, we write name. Protected, we put underscore before the name. We put, okay, so here practically not implemented in Python. So, it is, the concept is there, but it is not implemented. So it says, okay, protected member. So if I want display LOC or display state, okay, I want display state to be, so, okay, so now here, if you go and if you say dot, you see display location, display school, display state, all these are available here, right? So I'll say display state, okay, and your display state will be called here. Oops, self, right? I keep missing that. Okay, so your display state is here, right? Now I want to make display state as private. So to make it private, you have to give one underscore on the left, nothing on the right. One underscore on the left will make it protected. Underscore and then the name, member name. Okay, underscore member name will make it protected. Now when you go here in school, okay, you see that display state is not visible. Okay, because it is protected. Okay, because it is protected, Only the derived class can call it, not any other class, not anyone else. So it is available only to your relative, you can say. So it's like this, okay? Public is something that anybody can use it. So let's say you have something which anybody can knock your door and take it. Things which you make it protected, only you and your friends and relatives can use it. Okay? Protected, the third one is only which you can use it. You don't even want to give to your relative also. Something which is only available to you. Now here you see, I put this right display state, but display state is not used, is not shown here, not accessible. But I told you practically it is not available, right? Practically we have not. Okay, so here it will throw error because the name we have changed it, right? So practically, okay, we have, it is not enforced in Python. Okay, so even if you give here, okay, it will work. Okay, so yeah, somewhere we have, because we changed the name, right? So we have to change name everywhere. Display state underscore, right? Everywhere we have to change the name. Yes, fine. So see, when we did dot, PyCharm was not showing because PyCharm knows it is protected. Okay, that's why it was not showing. But when you called it, there's no error. So that's what I said. Protected concept is there, but it is not implemented. But private is implemented. Private, when you make something private, you cannot access it. Now, if I, let's say, I don't want LOC to be accessed by anybody else. Okay, so LOC is anyway here, right? It has its own LOC. That's not a problem. Let's make it private. Display state as private. Okay. Now, display state is private. So when, okay, so everywhere we have to make double underscore. So private is double underscore. Okay. Double underscore in the beginning, okay, not in the end. Member name. Okay. Can't be accessed outside the class. Doesn't matter who calls it. You cannot access it. You cannot access it outside the class. Okay, it's very private to you. Now, display state only we made private, right? Okay, display state. Now see, this display school is within the school. Okay, so it should be able to call. But outside, okay, outside we have here display state. This should throw error. Okay, now for a minute, let's comment this out. Okay, we'll just focus here. Now when you run it, so it says, see, myself display state, do you mean school display state? Okay, so this is not available. This attribute is not available because we made it private. So private is not accessible by anybody else. Okay, so you cannot, when you make it private, it cannot access. Now, so here it is not available. So, you have to probably give display location. So to make it work. So you see, it is not accessible by anybody else. Okay. Now, even here, if you try to use it, okay, it will not be. So if I say here, right? Okay. So now, if I go here and I say student dot display state, double underscore, right? Here again, you get error. So even derived class cannot use it. Even derived class cannot use it. Even ST1 cannot use it. Protected per theory, only derived class can use it. But when you make it private, even derived class cannot use it. So you cannot use it here. But here you see, the display school is member of the same class. So your family can use it. So still it's where we are located in the state is getting printed because display school is calling it. So protected can be called by the members of the same class, but not outside the class by anybody else. Is it clear? Did you understand? Public, anybody can call it public members. Protected members, only derived class can call it. Private, only the class which has defined it can call it. Nobody outside that class can call it. Okay, because it's your property, these are your members. You can decide who can use it, who cannot use it. So that is implemented using property called as encapsulation. So encapsulation uses underscore, double underscore, or nothing. If it is nothing in front of name, it is your public variables or public functions, public methods. If you put one underscore, it means it's your protected variables and protected functions. If you put two underscore, it means it is private, cannot be used outside, but within the class it can be used. Is it clear so far? Yes or no? Why it's so silent today? Okay, so this is your encapsulation. The fourth property is called abstraction. Okay, what does abstraction mean? Just like we are trying to hide the information here in encapsulation, we say that we try to hire um, uh, 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 the implementation. Abstract means, now again, that's again properties of class and objects. Let's say, when you are driving a car, okay, it's not important to know how the engine works, right? If you know how clutch, gear works, it's fine. For accelerator, brake work, it's fine for you. You don't need to understand the inner things of car. So what we are saying is, okay, in abstraction, you don't have to worry about the implementation detail. Okay, don't focus on implementation details. Okay, you as a user, you can only call and use the, okay, you can only use the um can only use the uh, what do you call um, mm, what is given to you, right? What is given to you. For example, I don't need to know how this located in the city has come. Okay. Okay. You want to know the city name, you say display city and you'll get the city name. How it is done, which is parent class, base class, how many levels, you don't need to know. Okay. So now let's say, okay, see, so far what we've been doing is we've been talking about parent class having a property and you are from derived class, you are using the property. There could be a situation where parent class will force the user to use a property. Okay, you are forcing the derived class to have their own property. Okay, so let's take another example. I'm going to move this for a second. So let's say you are defining a class called shape, right? And you have its own properties. Okay, and let's say you have def, okay, and you say print shape is created, okay, and now I create two other classes, class rectangle, okay, uh, and let me derive this from shape, okay. So this is derived from shape and you create rectangle and I say print rectangle is created. Okay, and here you have capital R, right? Now let's say we use class circle. Okay, and yeah, we'll say circle is created. So what happened? Okay, we created a class shape and we are creating two other classes, rectangle and circle. Now what I want to do is I want rectangle and circle to have a function called area. Now area of rectangle and circle is different, isn't it? So if you want to force these two classes to have this thing, you can create a area as a function. And you do what? You print and say, I'll do nothing. Okay? It's like this. Now, when you say area, okay, I'll do nothing. Okay? What happens to rectangle? So when you create a circle object, C1 equal to circle, okay? And then you say, when you say C1 dot, you will have area, right? And when you try to run this, you get message saying, I will do nothing. So, you'll feel embarrassed as a circle. Okay. That, it's saying that I will do nothing. No, why should I not do anything? I want to do something. So you are forcing circle to implement it. You are forcing circle to implement area. Otherwise, you will get message, I will do nothing. Okay. So in this case, what we do is we actually put, we call it as abstract method. Okay, so abstract method is not accessible just like that. You have to create abstract method. Okay, so you have to call this shape as object. Okay, and okay, uh, and even after creating object, you have to import, okay, something called as abstract method. Okay, so you have to say from ABC import ABC meta, comma, abstract, abstract method, okay, not abstract class method, okay, abstract method. And now I'm saying this is abstract method. Okay, this is abstract method, and I'm saying that this is a dummy class for this is creating a dummy parent so that you are forcing rectangle and circle to implement. Now when you run it, okay, so what happens to the circle? Circle will say, okay, sorry, let me create my formula for area. It's like this, you are not prepared for exam, okay, but your family member says, I will go and put you in the exam center. So you are scared of sitting in the exam center, so you'll start preparing. So circle has no option but to implement area, isn't it? Now, shape is not bothered because if I say S1 equal to shape, okay, and when you run it, okay, so shape is created, and here I'm going to say, I will not actually, call this init. Instead, I will say, okay, or let me call init and see what happens. Okay, instead I'll say here meta double underscore meta class underscore equal to ABC meta. Meta class equal to ABC meta. Okay, so you are indicating that this is a meta class. Okay, okay, it's a ABC meta. Okay, and okay, now when you try to call here S1 dot, okay, area, okay, you will get, I will do nothing. Okay, so which is fine. Okay, because nobody is interested in shape. but people using rectangle and circle will have to implement, okay, area. Otherwise, rectangle area cannot be I know nothing, or I don't have area. Rectangle cannot say I don't have area, right? So you are forcing derived class to implement these two, or this method, area method. And if you do not want, like, there could be third method, which is fine, okay, which is not a derived class, right? So you can say information, something like that. I can say print I belong to class shape. So this is fine. This has no problem, right? So this you can use it, okay? So I can say C1 dot information is fine. But I am forcing them to implement area. I'm forcing them to implement area. Okay. So what we're saying is, child can have access to parent and can have their own. Here, accessing parent is kind of burden for them because they have to implement it. There is nothing, the parent has not implemented it, so you have to implement it. Did you understand? This is called abstraction. Okay, this is called abstraction. So we finish class and objects. Okay, and with this we finish our core Python topic. We will tomorrow when we meet, we'll do this one, database. Okay, we'll see how to create our database from Python. Okay, so with database we will finish. Okay, so maybe we can talk about how to access files also. Okay, with files and database we finish our core Python. Okay, next week we'll focus on visualization. But before that, I want you to work on a project. Okay, so just give me a second. I'll open this project. Okay. Okay. Wait. Can you see? Where is that? Can you see the Word document?
No, Swapnil.
No. Okay. Let me have to share it again. Okay. So yes. So now you should be able to see, right?
Yeah.
Okay. So ignore this hint. Okay. This is to do it using pickle for kids. Okay. So ignore that. We don't want to use pickle. You'll be using database. So here you can say, okay, this is for option 2. Okay. But for us, it is option 1. Use database to get this implemented. So you can use MySQL or SQL Server or whatever database you want, you implement it. So this is a library software. Okay, and you have book issue, book deposit, admin menu. So initially, you'll on the screen you'll have book issue, book deposit, admin menu. Because see, admin menu you as a librarian you don't use very often. If new books arrives, a new student comes to library, then you will create a new record. Otherwise, issue and deposit, what will happen on everyday basis, right? So students should be able to issue a book. Students should be able to deposit a book. Okay. So this is these are the menu I want you to implement and perform this. I'm going to share the code maybe after 3-4 weeks. Okay. Before that, so this is supposed to test all your Python knowledge so far and implement using class and objects. Okay. I'll do share the code, but I'll share it after a week. I want you to, after 4 weeks, okay, after a month, I want you to try for next 1 month on this. So once you do this, your Python knowledge will be clear. So you use list, dictionary, database, class and objects, all these concepts you can use or you should use. Okay, I'll share this in the either in the link or on the group, WhatsApp group.